Hi there. Well, we're going to continue with the graphing in this section. And what we're going to be doing is we're going to be taking an equation and looking at the graph and some different aspects of the graph. So we have a bunch of little ideas to get across to you. I have some little ideas, and then we'll try to put all these little ideas into one. So again, we're going to look at an equation, and then we're going to look at the graph of the equation. But here, first off, let's look at an equation. I guess I really don't need this little graph right now. But let's start with a simple equation. Let's just say y is equal to x plus 2. All right, that's pretty simple. And so what I'm going to do is I'm going to find some solutions. And there's more. There's actually an infinite number of solutions to this. So we're going to find a few of them, and then we're going to plot those on our graph over here and see what they look like and talk about that graph and some of the things about that graph. So let's look here. Let's find some solutions to this. So what you do when you want to find some solutions to graph is that you pick an x or a y, and I'm going to pick x. I'm going to pick any x. Let's say x is 1, all right? If the x is 1, then y is 1 plus 2, which is 3. So we have the ordered pair 1, 3 will work in that equation. All right, if the x is 1, the y has to be 3. So let's pick another x. Let's say, how about 2? If the x is 2 in this equation, instead of an x, I'm going to write the number 2. I get 4. All right, so if the x is 2, the y is 2 plus 2, which is 4. Okay. There's another ordered pair that's a solution to the equation, and to check them, you put 2 in for x, 4 in for y, and make sure the left and the right are equal. I could put a negative in there. Let's put in a -1. If x is a -1, what's the y? Of course, we could just go on. We could make the x -2, -3, -100. I mean, we could go all day. You can make them fractions, but if you're going to graph, I don't recommend a fraction. So here we have y equals, our x is now a -1 plus 2. Well, a -1 plus 2 is a +1. Let's go ahead and find another one. Let's make x, hey, let's make x 0. That's kind of a nice, 0 is a nice number to work with, pretty easy. So if the x is 0 now, so x is 0, 0 plus 2 is 2. Okay. Well, what I'm going to do now is I'm going to take these ordered pairs, and I'm going to plot these ordered pairs on my graph, and we're going to see what we've got. So I'm going to take, 1, 3, 2, 4, -1, 1, 0, 2. Now to come up with these ordered pairs, I just picked any x. And you can pick any x. You just kind of want to think about your graph. You don't want them too big so that they won't fit on your graph. And these should fit on my graph. So I'm going to take my ordered pairs. We'll start with 1, 3. Now we know when we're plotting points, we start in our origin. We go on the x. Let me move this over so you can see my x. We're going to go on the x 1 and up 3. 1, 2, 3. So there's my first point, 1, 3. So again, on the x 1 and up 3. All right. So that's this point here, 1, 3. Now let's do 2, 4. So we're going to go from the origin, we're going to go over 2 and up 4 and make another dot. All right. And then let's do the -1, 1. So we go to our 0, 0. We go to a -1. That's the first number in the ordered pair. So our x. So we go -1, 1. There's our next point. And then we have the point 0. So we go to 0 on the origin, we stay there, and we go up 2 for our other point. So we now have these 4 points that are solutions to this equation, and we've drawn them here. We put them on the graph. Well, what an interesting thing is that if I connect all of these up, all right, and we're going to be talking more about this picture here in our next section when we do some more graphing. But if you look at this right here, when I connected these points up, I got a straight line. So we call this a linear equation because, I'm going to write that word linear once I get these all straightened out. So we have what's called a linear equation. So this is a linear equation. And notice the word line in there, because when you graph the solutions, the solutions themselves form a straight line. So when you take an equation and you graph the solution, you're actually getting a picture of the solutions to the equation. So the graph is a picture of the solutions for a particular equation. That means any point on here. So let's pick a different point. Let's pick, okay, the point, this point right here. I'm going to pick it, randomly pick a point on the line, is the point 3, 5. To the right 3 and up 5. That means if I put this into here, it'll be true. So if I put 3 in for X, the X comes first, 3. I put 5 in for Y, it will work in that equation. It's a solution. So here, let me kind of move it over a little bit. I'll go ahead and go through that process. 5 for the Y, 3 for the X. So 5 equals 5, all right? So again, the graph is a picture of the solutions for an equation. So what we're going to do is we're going to kind of look at this graph right here. We're going to kind of look at some of the ideas that come from the graph, and then we'll relate it back to the equation. So if you're given a graph, you can find the equation. If you're given the equation, you can find the graph, okay, by looking at some of these ideas. And, you know, sometimes it's a little easier than others, but for the most part, it shouldn't be too bad. All right. So, and again, the first thing we're going to talk about is the idea of slope. All right. So this line, we're going to look at some characteristics of our lines here. So one characteristic that we'll look at here is called the slope. Now, the slope of a line, we use the letter M for slope, and that's pretty universal all the way up through your calculus. We'll be using that symbol M for slope because it's strange, but we use S for distance, and then we use D for derivative. So we can't use S because that's distance. It's crazy. But anyways, that's all right. M, slope is M. So when we want to find the slope, what we're doing actually is we're finding the steepness of the line. How steep is this line? So it'll tell you the steepness, but the slope will also tell you the direction of the line. So what do I mean by direction of the line? Well, let me grab some more, if I have it. I don't want to have to pause the video, but I might have to. I want to look at some samples here. Or maybe I can just kind of sketch a graph with this. All right, so here, I'm telling you that the slope tells you how steep it is, but it also tells you the direction. So anything, as you think of it as reading from left to right, this line is rising. All of these lines here are rising. It doesn't matter if they start down here, it doesn't matter if they go through our origin, you know, if they go through here. All of these are considered to be rising. Left to right, they're going up. You would be going uphill from left to right, and that's really not a very straight line. So all of these, their slope would be positive. It will be a positive number because they're all rising. So the slope tells you direction. If they're rising, as you read from left to right, your slope will be positive. However, if they're falling, let's talk about here. If they're falling from left to right, it's like you're going downhill from left to right. All of these are, just, I can even put one maybe up here that's fairly steep. All right. All of these are falling from left to right. So in this example, the slope they're negative. They are negative slopes. So if it's rising, if the slope is positive, it will be rising. Your line, when you graph it, your solutions, the solutions will form a line that's going up. If your slope is negative, the solutions form a line that's going down. And every point on that line will work in the equation. Every point on the line will work in that particular equation. So again, we have a direction. Our slope gives us a direction, if it's rising or if it's falling. But the slope also gives us how steep it is. Is it really steep? Is it like you're going down 14A? Or is it maybe not so steep? Maybe you're going just, it's almost horizontal. It's pretty flat. So we have a value that tells exactly how steep it is. And then the sign tells you the direction of that of the line, if it's rising or falling. So what we're going to do is we're going to go through some examples on how to find the slope. We're going to talk about this first one. I have a picture of it. This is very similar to your homework. And let me grab a piece of paper so we can cover up some of these so it looks a little neater. All right. Okay, so here they want you to find the slope and they've given you the line. So we're going to find the slope given a graph. We're going to find the slope given 2 points, and we're going to find the slope given an equation. None of them are very difficult. You do need to remember that when you find the slope is a constant. So the slope of a line, its steepness doesn't change. If it changes, you've got a curve in your graph. But all of these will just be straight lines for your purposes. So here, the slope is a constant. It might be a positive number, it might be a negative number, depending on the direction of the line. And, it could be a high value, it could be a fraction. It's not very steep. Okay, we'll look at some examples. So the first thing we're going to do is look at the slope of a line given the graph. So the slope is actually, let's see, I'll write it right here on this assignment here. All right, the slope by definition is rise over run. And some of you may have heard this before. I'm going to use our M for slope. So the slope is the rise over the run. So our slope is a ratio. And then you just need to make sure you reduce your ratio. And if the ratio happens to be like 3/1 or 4/1 or 10/1, just do the 3, the 4, or the 10. You don't necessarily need that bottom number until we go from the equation to graph, and then you'll want that bottom number, that bottom 1. But if they ask you for the slope, you don't necessarily have to put that bottom 1 in. But when we're graphing, we will want it. All right, so what you need to do to find the slope given a graph is you need to find 2 points. Doesn't matter because remember, this is a constant. It's going to be the same no matter what 2 points we look at. So we're going to look at some points where it crosses a grid mark. That's the easiest thing to do. And there are numerous ones on this one. Oh, wow, there's a lot of them. So I'm just going to pick this one right here. It's pretty obvious. It crosses the grid right here. And the next one, oh, wow, crosses the grid right there. Okay, so there's 2 grids it crossed. Now, what happens if I didn't pick those 2? And we'll choose some other ones, just so that you can see that it will always reduce down to the same thing. No matter what points you choose, no matter what grid points you choose, it's going to work. Just that you may have to reduce more depending upon your grid choice. So what we're going to do is we're going to count blocks now. So the numerator is as you go from point to point, how far up do you go? That's the rise. So the slope, you could consider it a path from point to point. So we're going to go up 1 to get to this point from here. We're going to go up 1, and then we're going to go over 1. So we have the rise of 1 over the run of 1. So it's 1 over 1, rise over run. So it's how far up we went and how far across we went. And then you will reduce this. 1 over 1 reduces down to 1, just 1. The slope is 1. And ask yourself, is my slope positive or is my slope negative? Well, in looking at this, it's as you read from left to right, this graph from left to right, you're rising. So it's a positive slope. So your answer is 1. So it's just counting grid blocks in order to determine the steepness. So the steepness of this one would be considered a 1. All right, so let's look at another one here. Again, we want to find the slope of the line. So we're going to have to find some grid points here. Let's look. It looks like one grid point is right here. And another grid point where it crosses a grid, it looks like here. All right. So those are the 2 grid points I've chosen. And the last problem, I was going to look at some different grid points so that you could see that it would reduce. So we'll come back to that one when we're done with this one. I just want you to know that it doesn't really matter as long as you do have a true grid point. Okay, so we know, you can look at this. Okay, my slope is going to be positive because it's rising. And so we have the rise over the run to go from this point to this point. And I always go from the lower point to the higher point. So here I'm going to the rise. Our slope is rise over run. Let me go ahead and put that back again. So we're going to count the blocks. We're going to go up because we're creating a path from this point to this point. We're going to go up 1, 2, 3. Oh, you guys better be careful when you're doing this and make sure that every block represents a 1, because there are times, especially when you do like some story problems and stuff in some of your other classes, each block might be worth 50, or it might be worth 20. So if it's worth 20, then it would be 20, 40, 60 would be the rise. So again, be careful what each grid represents, what each block on your grid represents. And in this case, it equals 1, 2, 3, 4, 5, 6. So each one's worth 1. Okay, now, so we've gone up 3 blocks and we'll go over 4. 1, 2, 3, 4. So we have our rise is 3 over 4. All right, and again, it's positive because it's rising as you read from left to right. Now, let's back up here. I did tell you on this one that what happens if you didn't exactly choose that point, those points I did. What happens if you chose this point and one way up here? Okay, all right, those are legit points. They're crossing the grids at those points. So we do the rise, 1, 2, 3. Over the run, 1, 2, 3. So our rise is 3. The run, which means across, is 3. And when you reduce it, you get a 1. So again, you just had to do a little bit more reducing, but you are going to ultimately end up with the same answer when you reduce your the rise over the run, that ratio. So again, the slope is a ratio. All right, let's look at another one. Make sure that that you understand this process of finding the slope given a graph. Well, what's really nice is on this one, they gave you the points. They gave you a couple of points to use. So we're going to use those points. They have the dots for you. That's awesome. Now, if you look at this one, just make sure that you realize that this line is falling, so your answer will be negative. So the slope of the line is, I'm going to put a negative so I don't forget. Okay, so now we need to go from one point to the other, a rise over run. It doesn't matter if you go, you're going to go down, that's why it's negative, and across. all right? Or if you start here and you go up and over here, you know, just count blocks from one to the other. Let's start with the bottom one. So we're going to go up 1, 2, 3, 4, and we're going to go across 1, 2, 3. All right, so our slope is our rise. I'll put that here. You go up 4 to go to that next point and over 3. And we always leave these improper, so don't make them a mixed number. All right, it's important to leave it just as a fraction. So our answer is 4/3. That's our slope, 4/3, and it's negative because it's falling. All right. Well, I hope that so far you know how to find the slope. Well, what does the slope mean? And how to find the slope given a graph. Let me see. I believe we have a couple more to do. Yes, we do. These are kind of some special ones. Whoop. Let's look at this one right here. Okay. Here's our line, and it's a horizontal line. And remember that the slope measures steepness. Well, what is the steepness of this line right here? In other words, if you were driving on this road, would you be going uphill? Would you be going downhill? Well, here it's a flat road. It has no steepness. So in this case, this is called a horizontal line. That's a horizontal line. And the slope of a horizontal line, it is done really the same way. It's the rise over the run. But if you're going from point to point, how far up or down do you go? What's the rise in going from this point to this point? Well, there is none. There is no rise. We're not going up to get to this point, or we're not going down to get to this point. So the rise is 0. And the run is 1, 2, 3, 4. But when you have a 0 in the numerator, it doesn't matter what's down here, it reduces to 0. So the slope of this line is 0. All right. So any horizontal line will have a slope of 0. In other words, it's a flat. There is no steepness to this road if it were a road, or this line. So any horizontal line, your slope is 0. And you can go ahead and look at it and look at the rise over run if you need to, or you can just remember that these horizontal lines, the slope is 0. However, what happens if I have a vertical line straight up and down? All right, well, they didn't give us our 2 points, so we're going to put them in. All right, I'm going to put a point on it. It doesn't really matter. From here to here. You know, just pick any. Remember, it doesn't matter. We just have to reduce when we're done. So we want to find the slope of this vertical line. It looks very, very, very steep. So here, what is the slope? Well, we'll take our rise over our run. And then once we've done this, you'll know what the slope is of any vertical line. It's vertical. Vertical line. All right, so these are vertical lines, straight up and down, vertical, horizontal. So let's look at the rise. How far up and going from this point to this point? Well, we're going to go up 1, 2. How far across do you go to get from this point to this point? Are you going to the left 2, or you're going to the right a couple? Well, you're not going right or left any. All right, so there is no run. You're not going right or left, but you did go up. But here, this is 0. And well, so from the beginning of the not really, I guess, the beginning of this block, we know that you cannot have a 0 in the denominator in mathematics. It doesn't work. So there is a huge difference between a 0 in the numerator. You actually get a 0. 0 is a number. It's a value. It's an answer. But if 0 is in the denominator, we can't have that. So this slope is said to be undefined because we cannot have a 0 in the denominator. We kind of talked about that at the beginning of the block. So the slope of a horizontal line is 0. The slope of a vertical line, because you cannot have a 0 here, is undefined. So these two ideas, this idea you're going to, because I'm going to give you 2 points and we're going to have to figure it out. So if you run into this where you have a 0 in the numerator, the answer is 0. If you run into given, just points where we're just going to be working with numbers, if you end up with a 0 in the denominator, it's undefined. And they give you a choice for undefined here. The slope is undefined, your choice is B. Whereas for number 5, the slope is 0. Okay, so, all right. So that's all I have for graphing finding the slope given a graph. Now what we're going to do is we're going to find the slope given 2 points. Okay, so now we're going to look at how do you find the slope if you're given 2 points rather than the graph? Because, the graph is kind of nice. You just count the blocks, the rise over the run. Well, in order to find the slope given 2 points of your line, we're going to use an equation, and it's basically the same as counting the blocks. Now, we know from the graph that in order to find the slope, you take the rise over the run. Well, in order to find the rise, now, if you'll notice when you're doing the rise, okay, I'm going to get those back here. Let me get, here, we'll look at this one. Okay, the rise is the distance here of the y values. So in order to find the rise, you're dealing with the y values of the points. When you want to find the run, you're dealing with the x values of the points. So the rise is determined by the y values, and the run is determined by the x values of your points. This is an x distance, and this is a y distance. And whenever you want to find a distance between 2 things that are on a straight line, you can subtract them. So what we're going to do, we're going to use that idea. The rise is going to be, because the rise depends upon the y's, we're going to subtract the y coordinates. And I'm just going to put the 2, these are subscripts. It's read y sub 2 minus y sub 1. These just mean I'm going to pick from different points, okay? The 2 and the 1. It just means that we have 2 different y's. And the run going across depends upon the x's. So I'm going to subtract the x values. And that's the formula we're going to use in order to find the slope. The difference in the y's, okay, the y's along the y-axis, over the difference in the x's give us our run. So again, I'm going to come back to this. So what we're doing is we're finding this distance by subtracting the y's, and then we're finding this distance by subtracting the x's. So we have the rise over the run, the difference in the y's over the difference in the x's. That'll determine the run, is the difference in the x coordinates. I've had students really struggle with this. Some of the things that I've seen is they flip the x's and the y's. And I think that the reason they flip the x's and the y's is because the x's come first in the ordered pair, so they want to subtract them first. But we need the rise, which comes from the y coordinates. And the y coordinates are the second numbers in any ordered pair because they're in alphabetical. So try not to subtract the x's and put it here. Okay, you make sure you subtract the y's. And again, I think they just people want to subtract the x's because they're the first ones in the ordered pair. But you do have to subtract the y's, which are the second numbers, first. All right. And then I've had some students that just want to take 9 minus 0 over 10 minus 10. and and that's not right, because you want the y coordinates, and the y's are the second numbers and the x's are the first numbers. So let's go through this example. So we want to take the y's. Well, I have two y's. One of the y's is 0 and one of the y's is 10. Now, which one do you want to start with? Well, it might make it a little easier, but you don't have to. It doesn't matter which one you start with. I'm going to start with the larger, the 10, and subtract the 0. So I'm going to take 10 minus 0, because then you don't have to work with negatives. So I'm going to take 10 minus 0. You could have taken 0 minus 10, but then you end up with a negative 10 in the numerator. So I'm going to take 10 minus 0. That's going to be my rise. And the run, now this is important, because I started with this y, I have to start with that x underneath. You don't have a choice. So you have to stay consistent. If you start with that y in the numerator, you have to start with that y in the denominator. 10 minus 9. And then you just do your subtractions and simplify and you're done. So we'll take 10 minus 0 is 10, kind of running out of room here. And then 10 minus 9 is 1. So our slope is 10 over 1, but I'm pretty sure my math lab is only going to want the 10 rather than the 10 minus, or the 10 over 1. All right. So difference in the y's over the difference in the x's. Make sure you put the y's in the numerator. And then if you start with this y, you have to start with that x underneath. So let's do a few examples. I want to make sure you've got this. I need to kind of move this up a little bit there. Okay, here we have 2 more points. Find the slope of the line containing the given pair of points. If the slope is undefined, state this. Well, let's see. Let's go ahead. I'm going to take the difference in the y's over the difference in the x's. And again, these subscripts just mean they're 2 different y's and you have 2 different x's. That's all those subscripts mean. The 2 really, you're not going to be multiplying it or anything. Okay, we have some choices for our y's. Okay, we can go 5 minus 0, or we can go 0 minus 5. You know, it doesn't matter. Let's go ahead and take 5 and subtract the 0. So those are the second numbers. We start with the second numbers in those ordered pairs. Those are the y numbers, because these are in alphabetical order. Oops, that doesn't look like an x, but it is. XY and XY. I did have a better pencil. All right, so we have the difference in the y's, 5 minus 0. Now, because we started with the 5, underneath we have to start with the negative 2, subtract the other x. Okay. Simplify and you're done. 5 minus 0 is 5. Negative 2 subtract 5, or plus a negative 5, is going to be a negative 7. So our slope is a negative 5/7, and it doesn't matter where you put that negative. You could put it up with the 5, you could put it in the middle, or you can put it with the 7, as long as it's there. So this tells us that our line is actually falling. If you were to plot those points and connect them up, your line is going down because of that negative. It's falling. We could say it's decreasing, but that's okay. All right, hey, let's try another one. Let's look at number 9 here. Again, we want to find the slope. So our equation, can't count blocks, we're going to use our equation, difference in the y's over the difference in the x's. So okay, what are our y's? We have 2, okay, you've got 2 and 10. The 2 and the 10 are going to go in the numerator. And you can either take 2 minus 10 or 10 minus 2. Let's take 10 minus 2. which means I started with this guy. Since I started with this guy, yeah, I was looking at that last one, make sure I did that right. So we have 10 minus 2 in the numerator. The x's, I have to take a negative 10. I have to start with the negative 10 because I started with its partner here in the numerator. So negative 10 minus a negative 4. So you always have those subtractions stay. So you'll have a negative 10 subtract a negative 4 and a 10 minus 2. So it's the difference in the y's over the difference in the x's. Now we simplify it. 10 subtract 2 is 8. Negative 10 subtract a negative 4, or a negative 10 plus a positive 4. Two negatives is a positive. So we come up with a negative 6. This line's also decreasing, it's falling. But if you put this in MyMathLab, it would count it wrong. And it would probably give you this message saying, well, it's close, but it's not reduced. And so you do need to reduce these. 2 goes into both of these numbers. I'll just put that negative there. 2 goes into here, 4. 2 goes into here, 3. And you just have to have that negative somewhere. So you have a negative 4/3. Again, difference in the y's over the difference in the x's. I think we have some more. Because for some reason, people, I put the x's, I don't know, in the numerator. Oh, yes. Can't, and one reason why I put these in here is that way we can review fractions. All right, so let's go ahead and we're going to find the slope of this line given 2 points. So the slope of the line, is the difference in the y's over the difference in the x's. So let's start. Our y's are always the second numbers in the ordered pair. So again, I'm going to take 1/2 minus 1/2. So 1/2 minus 1/2. I pointed to this one first, so we'll start with the negative 5 underneath. So the x's are negative 5 and negative 9. Negative 5 subtract, you always have that subtraction, and negative 9. So 1/2 minus 1/2. Well, great, they have a common denominator. So when you subtract the numerators, 1 minus 1, you get 0. So if you have a half and you subtract a half, you've got nothing left. Here, this is a negative 5 plus 4. Oh, excuse me, because that's the answer. And you get a 4. Well, 0 over any number is 0. So our slope, click that guy, the slope is 0. 0 over a number is 0. All righty. Okay, I think I have another one. No, yes, I do. Great. Last one. And then we're going to look at how to find the slope given an equation, which is actually pretty simple. Okay, given these 2 points, let's find the equation. Let me move this other one up a bit. Sorry, this paper. All right, let's find the slope of the line given the 2 points. Okay, the slope is the difference in the y's, which are the second numbers. Almost did an x there. Over the difference in the x's, which are the first numbers in the ordered pair. So let's take, well, it doesn't really matter. Let's take a negative 5, subtract a negative 10. So we have a negative 5, we're going to subtract. The other one is a negative 10. And then in the denominator, since we started with the negative 5, we'll just go to this number. 7 minus 7. So I think you guys can probably see what's going to happen. This is plus a positive. So we have negative 5 plus 10 is positive 5 over 0. We cannot have a 0 in the denominator. So therefore, this, if you were to graph this, what would it look like? Well, if this would be a vertical line if you were to graph it. And the slope is undefined. The slope is undefined. You cannot have a 0 in the denominator. Going back to this number 10 here, looking at this with the slope of 0, if you were to plot those points and connect them up, you'll end up with a horizontal line, and the slope is 0. Okay, great. All right, so far, that's what we have as far as finding the slope. Given a graph, and then given the equation, given 2 points. Now we're going to look. All right, so we've talked about the slope, given a graph, how to find the slope, rise over run. We've given 2 points, how to find the slope of a line. That is the difference in the y's over the difference in the x's, and the y's are always the second numbers in the ordered pair. And when we're dealing with slope, there's another way to determine the slope given an equation of a line. So you can kind of look at the equation of the line to determine the slope. And what we have here, this is a template that we're going to be using, and there's 2 templates for an equation of a line that we're going to use. This template, and it's one that MyMathLab likes, is called the slope-intercept equation of a line. So this is called the slope M. Okay, so we have the slope-intercept form of the equation of a line. So we have this M and this B. Now, it's really important that in order to find the slope and to find what this B here, which has a meaning, and we're going to look at that, the Y has to be by itself. You have to have the Y by itself in order to use the ideas we're going to use to find the slope. So I'm going to give you an equation, and looking at the equation, and I have to make sure you understand that if the Y is by itself, you can look at the equation and see what the slope is. And the slope is the number in front of the X. It doesn't include the X. The slope is the number in front of the X. So we're going to look at a couple of examples. I'm going to give you the equation of the line in slope-intercept form. And given the equation in this form, you should be able to look at it to find the slope. And then we'll look at what does that B mean, because we'll have to know both ideas. So I have these 2 examples here, all right? In this first example, okay, the line is rising, so we know that our slope is positive. And can I get my Y equals mx plus B here? Yeah, there it is. Okay. Now, if the Y is by itself, this is the equation, and this is a graph of the solutions to the equation. Any point on this line would work in this equation, and the solutions formed a straight line. It's a linear equation because the solutions form a line. If the Y is by itself, the number in front is the slope. So I'm saying that the slope of this line here is 2. Now, for some reason, some people want to include, they say, oh, the slope is 2x. But the slope is a ratio of 2 numbers. And in this case, the slope is 2. So that's all there is to it. The slope is 2. Well, let's look and see. Is that true? Well, given a graph, how do you find the slope? Well, we're going to look at this point to this point. And I know to find the slope, and it's going to be positive, it's the rise over the run. Well, the rise is 1, 2, and the slope and the run is 1. So you've got a rise of 2. I hope I don't want to get too many numbers in here. Over 1. Rise over run, 2 over 1. Or you can look at the equation, and it's the number in front of the X if the Y is by itself. All right. So given the equation, I'm going to say, what's the slope? You can just say, you can look at the equation and say, oh, the slope is 2. That's not bad. Let's look at this one. All right, this one, the line is falling. So we expect our slope to be negative. Okay, we say that the values are decreasing here. And again, the y is by itself. This is the equation, and this is a graph of the solutions. And the slope of the graph should be the number in front of the x, because it's in this form. It's called the slope-intercept form. And so the slope of this line is a negative, not including the x. You don't put the x as part of the slope. The slope is just a number. It's just a ratio. The slope is a negative 3/2. So there's your m. I'll just use this m. It's really that easy if the y is by itself. Sometimes you have to move things and get the y by itself. It may only take a couple steps, get rid of what's being added, and then get rid of anything that's multiplied to the y. But ultimately, when the y is by itself, the slope is the number in front of the x. Okay. Well, we still have one more number here. We have the number 4 and we have the number 1. So let's look at that right here, but I'm going to come to some other examples to look at that. And that's this right here. I don't know if I can get that on there. Maybe if I were to fold this, I can get this equation. There, perfect. Okay, so we're going to use these examples to talk about that b. Well, if the m is the slope, the b is the intercept. The word intercept usually means if you intercept something, you meet it or you hit it. And the this represents where you hit the y-axis. Remember that when you look at all these points here, all of these points, the x value is 0. So if the x value is 0, then we know we have the point 0, 6, 0, 3, 0, 0. So this right here, this number is the y-intercept. Because if you make the x 0, all right, to find the y-intercept at x is 0, because all these points where it hits the y-axis, the x-coordinate is 0. You're not going right or left. So all of these have the point. See, this is the point 0, 3. It's the y-intercept. Here's the point 0, 6. This is the point 0, 0. Hopefully you can see that one. This is the point 0, -4. Those are the ordered pairs for each of these points. Now look at the equation. 6. Okay. Here, 3. Here, 0, because you're not adding, it's a plus 0. Here, -4. So when the y is by itself, you can find the slope by looking at the number in front, and all of these have a slope of 1. Rise over run, 1 over 1, 1 over 1, 1 over 1, 1 over 1. So the slopes are all 1. That's the number in front of the x. And so that's a good point, because you think, well, what is the slope? I mean, there is no number there, but in mathematics, we don't put the 1 in front of our variables if it's just the number 1. So you have to realize that it is a 1, but we're not going to put it in there, but it is a 1. So that's 1x, 1x, 1x. Another idea is, look at those are all parallel. So when lines are parallel, the slopes are the same, their steepness is the same, but you won't have to remember that till the next class. So we've got the slope, the number in front of the x, and the y-intercept is this number that's being added or subtracted. So it will hit the y-axis at 6, that's the y-intercept, and the slope is 1. The y-intercept, it'll hit the y-axis at 3, not the x-axis, okay? The y-axis, this y-axis at 3, the slope is 1. This will hit the y-axis, and this one's kind of a tough one for people, but it's a plus 0 here. You're not adding anything. So this line hits at 0. and the slope is 1. This line hits the y-axis at a -4. All right, see, it hits at a -4 and the slope is 1. Well, and then we'll practice some of these ideas. I've got more examples. So let's look at these two. We've already determined the slope. Let's look at this one that's going up here. The slope is 2, but where will this line hit the y-axis? At 4. Sure enough, it hits at 4. The slope here is a -3/2. Where does this line hit the y-axis? At 1. All right. And so, and really the only time people make a mistake, this is the main mistake I see, is they will put the 4 here on the x-axis. But you got to make sure that this is the y-intercept. This number out here is where it hits the y-axis. And we're going to use this to graph in our next section in the next video. This is where it hits the y-axis, and that's its slope. Well, okay, so we're going to practice that idea and make sure I have this recording. Yeah, okay. So we're going to look at some of your homework problems. I guess, probably try not to make this harder than it actually is. But there's, there's a lot of little ideas to try to keep straight. All right. So given this equation, find the slope and the y-intercept of the line whose equation is given. And I'm going to try to keep it pretty simple because I know we don't have a whole lot of time, but I do want to introduce these concepts to you. So here, the y is by itself. That's more than half the battle, is if the y is by itself. So the slope of this line is the number in front of the x. So it is given in what we call the slope-intercept form. The number in front, remember m is our symbol for slope. So our slope is 2/3. That's it. There's your slope, 2/3. The y-intercept, where it will hit the y-axis, not the x-axis, the y-axis, it will hit the y-axis at 8. And we're going to use those ideas to graph, but not in this section. We already have enough to do in this section. So your slope is 2/3. That means it's rising, going up to the right. Excuse me, and it's going to hit the y-axis at 8. Isn't that awesome? Okay, let's look at another one. 13. Find the slope and the y-intercept. And again, the y is by itself, which is more than half the battle. So once the y is by itself, then the slope is the number in front of the x. Now, if there isn't a number in front of the x, then and you do have an x, it'll be a 1. So here the slope is 6/7. It's the number in front of the x. Don't put the x there. The x is not a part of the slope. The slope is a ratio of 2 numbers. That's it. And it's positive, so it's rising. And where will this graph of the solutions, if you were to take a picture of the solutions, this graph would hit the y-axis at a -4. Oh, okay, I've got to back up. I just saw this. Type an ordered pair. So the y-intercept, and I'm glad I saw this because my math lab would have said it's wrong. All of the coordinates on the y-axis have an x of 0. So the x is 0, -4. 0, 8. All right. So you do need that x coordinate. So when you plot points along the y-axis, the x's are always 0. So there's your y-intercept, 0 up to 8, 0 down to a -4. Do we have another one? No. All right. So those are the only 2 that I have. So I'm hoping that was enough. And again, if you ever struggle with something, you can always do similar question. And I had to import these from another book because our book doesn't cover a lot of the graphing stuff that the course description says we need. So I had to import some of these from another one, but you should be able to do a similar question. Okay, so now what we're going to do is I'm going to give you these two and ask you to write the equation. All right, I'm going to give you the slope and the y-intercept and ask you to write this. I'll give you these two and ask you to write this. And I'll want your answer in slope intercept. We're going to use this template. And then we're going to talk about one more template and we'll be done with this section. You know, the idea is, see, these don't take you long. It's just that there's a lot of little ideas. All right, here, let's look at this first one. All right, find the slope intercept equation. Oh, sorry, let me move this up. This is number 14. We'll do a couple of these. All right. Find the slope intercept equation of a line that has the given characteristics. It has a slope of 2. So it has a steepness of 2, which means it's rising, fairly steep. And the y-intercept is 0, 3. And they want it in slope. They want to find the slope intercept equation. So they want you to use this form. You're thinking, well, why are they telling us what form to use? Well, it's because there's one more. So we'll have to, and it's in this assignment. So we'll have 2 forms to look at. But all we have to do, if we want, this is the slope intercept form, y equals mx plus b. 2 is the slope. So we're going to put a 2 there. The b is the y-intercept, which is the 3. They want the 3. You're done. Y equals 2x plus 3. So this equation has those characteristics. It has a slope of 2 and a y-intercept. It'll hit the y-axis at 3. Great. Let's look at another one here. I have a slope of 5/8 and a y-intercept of 0, -2. I know it's the y-intercept because the x is 0. Whenever the x is 0, it means you have to be along the y-axis when you plot that point. So we'll just fill in our template here. This is our slope intercept equation. It's the form of the equation. Y equals, the slope is 5/8. The y-intercept is a -2. And there's your equation of the line with those characteristics. It has a steepness of 5/8, and it's not quite as steep as the other one, as that one's a little bit higher. It's a little steeper, and it's positive. It's going up to the right, and it hits the y-axis at a -2. All right. Let's see if I have another one, or if we, yeah. That's the last one of those. So I'm hoping that's enough of an explanation for you to find the equation given the slope and the y-intercept, because we're going to look at one more template for an equation of a line. And this one, it's called the point slope equation. And again, I'm just trying to introduce these ideas to you so that when you see it again, it won't be quite so new. You'll have some basic understanding. So before we were using this. And the reason we were using this is we were given the y-intercept, like 0, 2, 0, 10, 0, whatever. And we were given the slope. So we filled in this template, but there is another template that you can fill in depending upon the characteristics of the line that they give you. And the other one, I just don't think that's quite focused enough, is this right here. This one is really a nice one to use because a lot of times we're not given this y-intercept. We're not given the 0, 10 or the 0, -2 or the 0, 4. We're not given this point right here, that where this is 10, -2, 4, or 5. We're not given that y-intercept. We're just given some random point, and not necessarily the one where it hits the y-axis. We're giving it some other points. And if you are given some other different point, you'll want to use this template. So here, they tell us find the point slope equation of the line having the given slope and containing the given point. So we have 1, 4. It's not one of these. We're given 1, 4. So we're going to fill this in. So we start with the y, that stays. Okay. The y sub 1, this is the y coordinate of the point you were given. So we'll have a 4. And m is m, it's the slope. Okay, so m occurs in both of them. All right, so our slope is 6. That x stays. And this represents the x coordinate of the point that you were given, 1. And there's your point slope. So you can see, this is the slope intercept. This is the point slope form of the equation. And we have a couple more to practice. So again, depends on what you're given, which one you would want to use. Now, if they gave you this one, but they wanted it to look like this one, if they give you this and wanted it to look like this one, you would just solve it. You get the y by itself. You add 4. So it doesn't take too much algebra. Okay. So now we know where this line hits the y-axis at a -2. Even though it wasn't given, we now know. And it still has a slope of 6. That has not changed. The slope has not changed. The slope is always a constant. But now we know where it hits the y-axis by just kind of starting with this template and then getting the y by itself. Let's look at another one. Or we have, oh yay, we have a bunch of them to practice. Okay, and some of these are multiple choice, so that's good. Okay. Here, I want to go back to this one. So this would be y minus, you would put a 4 here. From the 4, the y sub 1 equals the m is 6, x minus the x coordinate of 1. Okay, so that's how you'll fill that in. It's a little strange. Okay, let's look at this next one. We're given a slope and a point, and we're going to use the point slope form. I'm going to write it again. Here we go. We've got y, that's always a y. The y coordinate, this right here represents the y coordinate of your given point. And the y coordinate of the given point is 3. The slope is a -9. Oh, this one's kind of going down. It's decreasing, it's falling. Because it's negative. You always have that x there. We'll put that in. Minus, we have that -2. Okay, so there's your equation in the point slope form. And again, you can multiply it out and bring the 3 over. And this one is a multiple choice. So let's see, it looks like it's going to be B. It matches with B here. Okay. Y minus 3 equals a -9, x minus 2. Perfect. Let's try another one. Again, this was also multiple choice. All right, we're given the slope and a point, so we're going to use this because we're not given that y-intercept. We'll use y equals mx plus b. Okay, so y minus our y coordinate is 8. Our slope is 2. X minus our x coordinate is 7. And we'll find our answer. Y minus 8 times a +2, x minus, so it looks like it's C would be our answer there. All right, last one. So there's only 19 problems in this homework. Well, this is awesome because I have a couple negative points. What does that do? We have y So we're given our slope and a point, but it's not the y-intercept. So we're not going to use the y equals mx plus b. Y minus y sub 1. We're going to fill it in. Now, if they had given us, if the point they gave us was like 0, 3, then I would put the 3 there and the slope here. But we're not given this information. We're giving a totally different point with no 0 here. You have to have a 0 here to fill this one in. So we'll take y, subtract a -2. A bunch of pencil marks there. So we have y subtract, we have that subtract a -2. The y is a -2. The slope is a -6. Look at all these negatives. X subtract a -3. Well, these two negatives are a positive. X plus 3. And that's what they're going to want. So you got to do a little simplifying with those negatives if that happens. And then you'll just look for the answer. Let's see. Looks like it's E this time. Okay. All right. So there's your, those are the two templates. So wow, we talked about how to find a slope given a graph, how to find the slope given 2 points, how to find the slope given the equation, and how to find the y-intercept, and then how to either come up with an equation if you're given the y-intercept, how to find the equation if you're given another point. Those are the ideas that you need to know for this section. The other section we're going to be graphing. So I'll be getting on MyMathLab to show you how to graph using Pearson. So that's all. So if for some reason some of these ideas don't you are confusing to you, let me know. Thank you. Bye.